We will be solving move zeros at the end. Let's take a look at the problem statement. Given an integer array nums, move all the zeros to the end of the array. The relative order of the non-zero elements must be preserved. The operation must be performed in place, and no extra array should be used. Input format. Multiple test cases, each containing an array represented as comma separated values. Constraints. The length of the array should be greater than 1 and less than 10 raised to power 5. The values inside the array should be greater than negative 10 raised to power 4 and less than 10 raised to power 4. Output format. For each input array, print the modified array such that all non-zero elements appear first, followed by all the zeros. So this is our sample input. Before going into the code, the idea behind the solution is a two-pointer swapping technique. One pointer called j always points to the position where the next non-zero element should be placed, which effectively corresponds to the first zero in the array. The second pointer I scans the array from left to right. Whenever I encounters a non-zero element, we will swap it with the element at j and then move j forward. This way the non-zero elements are pulled towards the front and the zeros are pushed towards the end, and the relative order remains the same. So starting off with pointing j at your first zero element and I one space to the right of it, we compare. Since both of them are 0, we will just increment I. Now I points to 16, which is a non-zero element, hence we will swap the values. So this will become 0 and this will become 16. J is still pointing to 0. J will continuously point to a 0 throughout the whole traversal. Now I will increment and it will point to minus 11, which is a non-zero element. So we will swap the values again. This will become 0, this will become minus 11. Then we will increment both the pointers again, and I points to 6 and j points to 0, which is now I points to a non-zero element, so this becomes 0, this becomes 6. Both are incremented again. Then j points to 0 and I points to 10. 10 is again a non-zero element, so this will become 0 and this will become 10. Now as we reach the end of the array, we see that j points to 0 and I also points to 0. So we stop here. Now moving on to the code, the execution begins from the main function. We will have a number of test cases, so that is represented by your integer t, and we use a loop, the while loop, that runs through every test case and it handles all your independent arrays. For every test case, we will read the size of the array, which is n. Then we create a vector of size n, and that reads the array elements. The values will include positive, negative, and 0 numbers. Now initializing the first pointer. We initialize pointer j to 0. This always marks the position of the first 0, or the position where the next non-zero element should be placed. Then this loop is the core of the solution. Pointer I scans the entire array from left to right, and if the current element is non-zero, we will swap it with the element at position j. Then we will increment j. Now once the array has been rearranged, we will just print the result. So on running the code, we see that it has passed the sample test case. On submitting it, it passes all the test cases. Thank you.